Geometry starts with what are called points, lines, and planes. We're going to be talking about the vocabulary in geometry. Now, it might seem a little difficult because we're just getting into the vocabulary. So the first unit, it actually feels a little hard, but just hang in there. I promise it's going to get easier. To begin with, we're going to talk about the most basic building block of geometry. That's what we call a point. A point is the most basic building block of geometry. It has no size. It is just used as a reference. Matter of fact, it has a circular shape, but it's just for me to be able to point at a specific place. So I might come over and and do the point, but I'm going to be labeling them. Since I might want you to look at a point or a different point, you may be changing views from a point to a different point. They're going to have letters, and usually we use just one letter. So the way we're gonna name it, in this case, I have the point A. The way we name it is just by calling out the letter A. So I might even ask you guys to for the distance between A and B. I might say, give me the distance between A and B, and with that, I'm talking about the distance between point A and point B. Remember, notice how I just uh, talked about them as a letter. Give me the distance between A and B. Once again, when we use just one letter, it's usually about a point. Now, we're also going to talk about what we call a line. A line is something that is straight. It's a straight, continuous arrangement. Continuous arrangement, what I mean with that is it has no gaps. There's no holes in it. It is continuous. So it is a continuous arrangement of infinitely many points. So something straight that it has no gaps and it goes on forever. The reference of a line, it's there. You guys can see I have a line there. And I call it reference because look, I have arrows on each side. So with that, I mean it goes on forever, both ways. So that's what I call a line. Technically, you cannot draw a line because you cannot go on forever. You can reference a line, but you cannot draw the line. Now, the way we're going to name a line, you must give any 2 points on the line. There could be more than two. I'm just asking any 2 points on the line and place a line symbol above the letters. An example, let me give you guys a line. Notice how there's more than 2 points. I labeled 3 points in this case, and I'm asking for the name of the line. Right? The way we're going to name it, I can go line AB. Right? I just chose 2 points. And notice I did a line symbol on top. Notice I have my arrows on each end. It goes on forever on each side. Then I also label this line BA. Notice I'm using the same two letters. Remember, my thing was any 2 points on the line. I never talked about any order, at least when it comes to lines. You could also call it line AC, line CA, line BC, line CB. Right, I came up with 6 names, and that is the same line. Any 2 points on the line, and on top of it, make sure you guys draw the line symbol above the letters. Now we're also going to be talking about what we call the line segment. Now, a line segment consists of 2 points, which we're going to call the endpoints. So it is going to end on each side and all the collinear points in between them. For an example, there's a segment AB. So remember a line, it kept on going forever on each side. Now the line segment, it stops on each side. Now look at the way I named them. Remember the line, let me reference that I'm using the arrows on each side on a line. But look at the line segment. I don't have any arrows. I'm saying it stops at A and it stops at B. So that's why we call those endpoints. And then the way you write the order of the letters does not matter. I can call that segment BA as well. Or segment AB, segment BA. As long as you use the two endpoints, in this case, the order does not matter. So we can reference a line. We cannot draw it because it goes on forever, but we can draw a line segment. Now, array, it's another word we're going to be using. Array is a part of a line that it only contains only one endpoint. But let me remember a line. Remember, a line goes on forever on both directions. Now, a line segment, it has one endpoint. So one side is an endpoint, and the other side, it goes on forever. So it looks almost like a line, but on one side, it has an endpoint, and the other side, it goes on forever. So that's what we call the ray. Now, on the line, remember I said any 2 points on the line AB. Now, for the ray, you're also going to use 2 points. However, make sure the first point is the end point. Remember, the end point is right where the ray stops. And that's where you're going to start naming it. So I call this the ray AB. I could also have called it the ray AC. Notice in both cases, I start with the letter A. Now, what ray AB truly means is you start at A and you go through B. So you go through B. That's what AB means. Now, AC, the ray AC, it says you start at A and you go through C. Notice in this case is the same ray. So I could name it either way, ray AB or ray AC. Now, if you guys come over it and you name it ray BA, that one is wrong. Because that one you're saying you start at B and you go through A. What that one will give you is you start at B and you go through A. So that's why I'm just like, yeah, that one will be wrong. So that's the difference on the ray. Now a segment, just for us to remember. When it comes to the line segment and when it comes to the line, the order of the letters does not matter. But when it comes to ray, the order of the letters does matter. Make sure you start with the endpoint. Now, two rays, we're going to say the two rays are opposite if they go opposite directions. So one ray goes one way and the other one goes as far as possible. That's what we mean with two rays that are being opposite. So an example, let's take a look at the ray PQ and PR. PQ, what that means is I'm starting at P. As a matter of fact, let me start drawing it on top. I'm going to use this picture twice. Just want you guys to see that PQ, it says you start at P and you go through Q. So it would look like that. On the graph, but I'm just putting the reference on the top. PR means you start at P and you go through R. Once again, I just drew it above the picture, but we can see that they go opposite directions. One goes to the left, the other one goes to the right. Now, another case we could do is the ray RP. Let me take a look at the ray RP. What that means is you start at R and you go through P. So it goes this way. And we also have the ray QR. That one starts at Q and goes through R. One goes to the left, one goes to the right. In my first example, PQ and PR, notice how they only share 1 point. My second example, they overlap a little. To be honest, when it comes to opposite rays, we don't care if they share a point, they overlap, or they might even have a gap in between. All we care that they're two rays and they go opposite directions. I could have a ray here and I could have another ray here. There's a gap in between them, but they go opposite directions, so they will also be called opposite rays. Now, a plane is it's a flat surface that extends infinitely along its length and width. So it's a flat surface that goes on forever along the length and the width. You guys heard coordinate plane in your algebra class. Remember there was an x-axis and a y-axis, and your teacher called it coordinate plane? It was flat, and it extended on forever. So for us to see it right now, imagine you're in your room right now. Each of your walls, it's a flat surface. Now in your mind, imagine it continues on forever. So each of your walls, it's a plane. The ceiling is another plane. It's a flat surface that extends forever. And the floor is another plane. For us to make it a little more visual, let's say that this brown plane, let's call this the wall of your room. The blue plane, let's call this the floor of your room. So I'm just looking at a wall and I'm looking at a floor. Right? They're flat surfaces that extend on forever. The cool thing on planes as well, as long as lines and all these things in geometry, we have this thing that we called intersection. Intersection are points that they both share. Right? If I, for example, look at one point, let's say I look at this point, let me call it point A. Point A, you notice, is only on your wall, not on the floor. There are points that can be on the wall, but not on the floor. Now, if I look at point B, look at that one. That one's on the floor only, but not on the wall. Right? That is possible. But imagine my point C. That one is actually in both. In your case, if you look at the wall and the floor, that's basically right there by the base. Right? There's a point that is actually in both. That is what we call intersection. But in this case, there's more than one point. I could think of point D, point E, point F. As a matter of fact, I could think of many points that will create a line. The intersection of two planes is a line. Intersection is the points that they share. Now imagine I had a line, and imagine I had a ray. In this case, the intersection is just one point. Intersection is the points that they both share. Now, coming back to the idea of a plane, let me just take a look at just one plane. Imagine this is a flat surface. Imagine it goes on forever. Notice I have 3 points in there, RST. There's 3 points. But look at V, that's idolized. It doesn't have a point. That's not a point. So there's only 3 points and there's another letter. The way we're going to name a plane, we're going to use 3 non-collinear points. So 3 points that are non-collinear on the plane, or simply by using the script capital letter. So I could call this plane RST. The order of the 3 points, it doesn't matter. I could call it RTS or however you want. Just those 3 letters, RST. Or I could also call it plane V. That V there is just for name. So I could call it plane V because that's not a point. I cannot call it plane R because R is not a name. That's a point. So I can either use 3 non-collinear points or the script capital letter. For planes, if you're going to be using points, you need 3 of them. When it comes to lines, rays, and segments, you only needed 2 points. But for planes, you need 3 points. All right, I just use the word non-collinear. So let's talk about what collinear means. Co means in the same, right? Think of your PE classes. You have co-ed teams. You're in the same, 2 genders are in the same team. Now, linear sounds like a line. Collinear means it's on the same line. So an example, I have 3 points that are collinear, right? They're on the same line. Coplanar, we talked about co already. Planar sounds like a plane, so that means they're on the same plane. That's coplanar. There's 3 points. Now, here in geometry, we're going to be labeling things. I can give you guys the names. Like, for example, look at my angles. Look at my angle 50. I can label it with a number 50. I can label it with a little arc. Now, look at my angle 30. Notice how those, I mark them different because they're different measurements, right? Angle 50 is one of them. The other one's angle 30. So they're different measurements. If I look at the third angle, I'm going to label it the same way I labeled the 30 degrees because they have the same measurement. Now that's how I'm going to be labeling angles with arcs. When they have the same measurement, I do the same amount of arcs. If they have different measurement, I label them different, as you guys notice. Same thing with sides. Notice how AB is measurement 8. The distance between A and B is 8. But look at the distance between C and D. That's also 8. So I could label them with the slash. That's how I'm going to be labeling sides. So looking at this, looking at my angles, I gave you the one angle's 50, one angle's 30. I didn't give you the measurement for the other one, but we can tell that this is 30 degrees because those 2 marks are the same. I know it's the same picture that I have on the top, but if I didn't have the one on the top, I can figure out that's 30 degrees because they are labeled the same way. Now, when it comes to the sides, right, CD is 8, AB is marked the same way. I already know that's 8. Some cases you might not know the measurement. I don't know how big is the segment AB. I don't know how big is the segment BC. I just know they're equal because they mark with the same slash. Sometimes in geometry, we just care whether the segments have the same length or not. We don't care about the number. Now, on a ruler, let's talk about how to use a ruler. Now, rulers they have two measurements, inches and centimeters or millimeters. Now, in inches, in between each number, so in between 0 and 1, there are, if you count how many spaces there are 16 spaces. So I'm going to say the first the first space is 1 over 16. The second one will be 2 over 16. The second one will be 3 over 16. 4 over 16, which can be reduced as 1/4. Technically, the second one, 2 over 16, I could have called it 1/8. Now, what if I want to see this as decimals? 1 over 16th, the first one, if I want to see this as decimal, I can easily type on my calculator 1 divided by 16, and that is 0.0625. The second one, 2 over 16, that is 0. So the second one, if I want to see this as decimal, 0.125. The third one is like 0.1875, then 0.25, and so on. So in my case, I'm not going to be using inches. I'm going to be using centimeters. Millimeters is part of centimeters, but looking in between the centimeters, in between each of my numbers, if you count how many spaces, there's 10 of them. If you want to see this as a fraction, the first one is 1 out of 10. The second one, 2 out of 10. 3 out of 10. 4 out of 10. On and on and on. As decimals, you can easily see it as 0.1, 0.2, right? The first one is 0.1. The second one is 0.2, 0.3, 0.4, 0.5. So in centimeters, it's a lot easier to measure. So I am going to be using centimeters. Now I'm going to ask you guys to measure segments. I'm going to give you guys a segment here. If we have a ruler that we can easily move, right, we can move this. But the way we're going to do this, the way we're going to measure a segment, I'm just going to see that my first one, my endpoint, the measurement of one of my endpoints is 1.9. Right, I want to see where did it end on my ruler, 1.9. I look at the other endpoint. This is 8.6. For me to know the distance, how big is this segment, the length of the segment, just subtract those two numbers, 8.6 minus 1.9. I'm going to use a calculator for this, 8.6 minus 1.9. It tells me that this segment is 6.7. I'm going to ask you guys to measure everything in centimeters, so just decimal, type in 6.7 for your homework. In the homework, I'm going to label it ST, and I'm going to say measure the segment ST. But that's what we do. We look at the measurement on the ruler, we subtract the two numbers. If I had a physical ruler with me that I could move along, I will try to make one of my numbers 0, just because it's easy to subtract 0. Remember, I have to subtract my two numbers, so might as well make one of them a 0. That's what I would do if I had the ruler in front of me. Let's take a look at another example. If you look at the endpoint here, this is 1.6. Looking at the other one, this is 9.1. I'm going to subtract these two. 9.1 minus 1.6, I get that this segment is 7.5. Get the numbers of your endpoints and then just subtract them. Let's take a look at another example. This one, the first endpoint is 0.8. The other one is 10.2. The other endpoint is 10.2. For me to know, remember I'm looking at these segments here. For me to know how big is that segment, just subtract those two values. 10.2 minus 0.8, and that gives me 9.4. Pretty simple, right? Now, this other segment, I'm not going to give you which numbers I'm subtracting. I kind of want you guys to do it on your own. You should get 7.7 for this one.